Welcome back to week 2. So this is lecture 3 of 210. So today we're going to cover what's called Web 1.0 style server-side scripting. So this is the beginning of the Web 1.0 section, which is the kind of oldest style of way of making web applications. So this is started basically in the 90s when the web was born. Today the objective is by the end of today you should be able to write a server-side script that dynamically generates a web page in response to user input. So the user should be able to give you some input, and your script or program should run on the server and do something and then make a web page and give it back to the user. And last time, I just want to recap from the end of last week, we showed how web servers are this combination of hardware and software that deliver static resources, such as web pages and images over the internet using HTTP. So we talked about static resources, which means things that don't change. So a file, a web page, a picture of a dog, a picture of a cat, a movie file. These things someone uploads to the server, it's there, and the server can fetch those resources and deliver it over the internet. And the protocol or language they use to deliver this is called HTTP. So it's some text-based language with some header, and then there's a body. Either it's HTML file or a bunch of ones and zeros that represent an image or so forth. So I'm going to review that briefly and then go over into the main event today. We have a lot to cover, which is all about dynamic web pages. So let me go through the recap for last time for review. So recall I have my browser open. So this was a lecture1.html. This is like the HTML file we constructed in the very first day of class. And I hosted this on my web server. So when I hit reload, it will load this web page in my browser. So I remember you can do inspect element and see the network. I have to stretch this up. If I see the network, let's see, if I reload, it should show all the, this is down. It should show all the parts coming with a timeline, right? So this thing is still a little bit too big. So it should show the lecture HTML file being loaded first, and the timeline, and then when it finishes getting parsed, it knows it needs to load a truck.jpg picture, and there's a little icon to load. So mainly it's just the HTML file in the truck. So we showed how this is being delivered to your browser over the internet, and if I copy and paste, I should be able to do the same thing on the command line with this curl or curl program. If I just paste the URL, those of you with Mac or Linux computers, you probably have this program. With Windows, you have to install it. But you're never going to actually use this manually, but I just want to show that this is just a program you can run to get data from servers. So when I run this, recall that the output to the command line is a header, which is the HTTP header that says this is HTTP, this is a piece of HTTP data, the server name, some date. Most important thing is content type. So this is a text/HTML I'm getting. There's some other data also, but this is basically the header of the HTTP. And then there's the body of the HTTP, which is all the way after a blank line. So down here in the body could be anything, any text or binary data you want. So the data here, it says, I expect text HTML to go in my body. So then the command line just prints out, this is the HTML web page that I requested. And it just prints it out. So the web browser does the exact same, where's my browser? The browser does the exact same thing. Just close all this. And except the browser knows how to display it in a nice format with fonts and pictures, and also request the picture. So recall that I can just request the picture from my server as well, but it'll print out junk to the command line terminal, because the terminal only knows these are ones and zeros and doesn't know how to actually take a picture. But whereas if I go to here, if I say truck.jpg, the web browser does the exact same loading procedure, but it knows how to interpret those ones and zeros as a picture. So that was last time. That was using a web server to serve images and text. So this is all good for a long time. I mean, you can make some pretty good web pages this way. I mean, obviously a lot better than looking at what we wrote in class, but you can imagine making your entire blog, entire personal homepage or professional web page by writing HTML, putting some pictures in, putting some nice CSS styles, and just uploading to a server, and we're good. Like that has worked for many web pages in the world work like this, and it's just a web page, just a document with some pictures in it and some nice style, and we're pretty much done. All right, so but obviously the class is more than just 2 lessons. So what are we going to do for the rest of the class? So let's go to Amazon, the homepage. This is from yesterday. I'm just going to reload it. If you visit the Amazon homepage, it redirects you to some other page, but just pretend like this is the homepage. So I click yes, Amazon, and something happens. So what am I seeing here? I'm seeing an HTML web page, right? This is just HTML. If I do inspect element and view the source code, view page source, actually, I can do Control U on Windows. This is, well, there's a lot of JavaScript here, but there is a lot of HTML. If you stare hard enough, there's actually a lot of JavaScript code, but it's not the best example. But yeah, so there's a bunch of HTML. So there's product images. It's all kind of squished together like this. There's more HTML. There's like the Canon camera here. There's a link to an image of the camera. There's all sorts of stuff here, right? So every web page you go on the internet, you can just go view source and look at all the code. Well, there's CSS right here. So notice this looks like CSS syntax, like style type CSS. So these are actually the styles for the Amazon homepage, all these different looking styles, right? So if I showed you this page, somebody could have just written this by hand, right? Like somebody, a really hardworking person at Amazon goes overnight, looks at the latest movies out and the latest, what other customers are looking at right now, all the hottest items, all the hottest video games and phones and everything, and they can just write out all this HTML by hand every single day, right? Or actually every single minute, because I'm sure if I reload, it might change. Yeah, look at that. Something changed. Maybe it didn't change, but you can imagine this changes, right? If you visit this in an hour, the hottest items are going to be different. So clearly you don't want to write this by hand because it would just take forever to update. I mean, you have to manually write all this HTML. But with what you've learned so far, you basically have to write all the HTML by hand. All right, so what's the solution here? The solution is we want to be able to write programs or scripts or computer code that can generate these web pages for us in some automated fashion, because we don't want to write HTML by hand because it'd be way too tedious. So conceptually, how this all works is Amazon has this giant database somewhere on its server of all the latest movies, the latest purchases by people, the hottest items, all this data about customers. And there's some giant script or program that runs on the Amazon server that whenever you visit the homepage, it will make queries to the database. Wow, look at that Halloween minions. Yeah, look at that. Very timely. This is clearly not going to be in season next month or 2 months from now. But right, so it says, what's the latest thing in Halloween? What's the top seasonal thing today? We grab those pictures out from the database, we construct them together in some web page, and then we serve it to you. So every time you visit this web page, it might actually look different. Even though the program someone wrote, they probably only wrote once, but the web pages they can generate, say, an infinite number of them, depending on when you visit and everything. So today's journey is really going to be, what is a dynamic web page? So this is really what we just sort of started covering now. A dynamic web page, instead of a static one, is one that's generated by some code on the server so that it can change, right? It doesn't have to be just a fixed thing you write by hand. So what the readings covered is this technique called CGI, for Common Gateway Interface, which is this very old school technique for generating web pages using scripts or programs on the server. So there's many more modern ways of doing it now, but this is the most straightforward and basic way to do it. So we're going to illustrate it in the first part of the class, because this is just showing that there's actually no magic behind the scenes there. Whereas if you use a lot of modern web frameworks, there's all sorts of layers of abstraction. You don't actually know what's going on underneath. But underneath, it's basically just doing what the CGI scripts are doing. So before we do that, I'm going to take a little bit of a detour. So recall that the web page here is being hosted on a server, pgbovine.net. That's my server. So we're going to draw this familiar server picture here. So this is a server, and this is my personal server in Texas or wherever I'm renting it. There's a web browser here, which is us. We make a request to this URL. The server fetches, there's some file here called lecture1.html, and there's a there's a file called truck.jpg. Handwriting is getting terrible, but you can see it. So there's a truck picture and there's a file. What the web server software does is it looks at my request, processes it, says, oh, I want lecture1.html from this domain. I grab this file, I encode it in some way, and I send back through HTTP, through the language HTTP, I send back these the contents of the HTML file to your computer. So hopefully this picture we've seen several times should make sense. All right. Let me know if there's any confusion on this basic picture. This is how all web page requests work. You're on your computer somewhere, you go over magically the internet here, and you go hit some server. And you know to hit the server because pgbovine.net routes you magically through the magic of the internet to this exact server. And we won't cover how that works in this class. If you're interested, take a networking class. This is fascinating how your computer manages to go through the wide internet, with all these cables in the world to find that exact computer. But we're assuming, look, we found it. Okay, so we have this connection. So for your projects and for me demoing in class, this is a little bit unwieldy because you have to rent a server somewhere, you might have to pay for it, you might have to maintain it and set it up. For the demos in class and also for your project, you can rent a server somewhere if you want. There's some free services we'll tell you about, or paid ones. But really what you can do is you can run a server on your computer. So really, you can imagine this server is actually the same computer as your actual laptop. So this is kind of weird, but there's no reason why the server, wow, I made a lot of dots here. There's no reason why this server needs to be a different computer than yours. The server is just a computer, right? So there's no reason why the server can't be your same computer. So I guess the way to draw this diagram is maybe like this. This is going to be a terrible drawing, but here's your giant laptop, the tiny keyboard. There is a piece of software on your computer called a web server, and then there's also a web browser here called Chrome or whatever. Does that make sense? You're all on one computer. You're running a web server called Apache is a common one. Nginx is a common one. You don't need to know the names, but Apache is the most common one, as we saw. You can run this software on your computer. You can also run a web browser on your computer because your computer runs a bunch of software together. And then what you can do is you can set up a local network on your own computer. So you pretend like this is the internet, but it's not. And then you're making requests to your server and it's going back to you. Does that make sense? So you can do that all without being connected to the internet because there's no internet here, right? There's a fake kind of network inside your computer that allows you to test this stuff. So for all the demos in class and even for most of your projects, the only thing we're going to require you is just to set up something on your computer. And again, when the project time comes, I'll show you all the way set up. Was there a question here about it? Okay. Any questions about this setup? Yes?
Would it still use HTTP to communicate?
It's a great question. Would it still use HTTP? Yes, it absolutely will use HTTP. It's going through the exact same channels as though you were over the internet. That's a great question. So because nothing changes. Your browser doesn't change, the server software doesn't, nothing changes. Yeah?
Does it even, I'm just curious, does it leave your computer?
No, it never leaves your computer. That's a good question. Yeah, so it never leaves you can be not on the internet, and this will work. Because your computer's operating system has functionality for connecting to sockets on the network. And it happens that you can create a network just on your own computer. So there's a bunch of system administration stuff to set this up. So usually what happens is the best way to set this up is you just download some software that already sets it up for you. So there's a few of them on Windows and Mac. I'm trying a new one this term. It's called AMPS or something, AMPPS. It's on your download link. So I've downloaded it and installed it. And what that is it basically sets up this software, sets up a local server on your computer, and it tells you where to put your files if you want it to be served on the computer, and it starts it up for you. So I am going to erase this image and then show you what AMPS is. Again, you don't need to set this up if you don't want to. For the class demos or for the project, you should probably set it up, and we'll go through a tutorial on that in class. So this AMPS thing is it basically is some dashboard that says the Apache server is started. I can click stop to stop. MySQL is a database that we'll go over. We can go over later, but for now, the most important thing is this Apache web server has started. So it started on the computer. So what does that mean? That means that I can actually put files in a certain location on my computer. So this location, if you really squint hard, is C, which is my home, program files, amps/www. This is just a directory. So by default on Windows, it installs in here. And Mac, I'll put up a tutorial later for Mac users, but it'll install somewhere, right? And then there's some www directory or folder, and anything you put in that folder is what the server sees as its files, like on the server. So for example, here I put a bear picture, a cat picture, dog picture, and then some and the lecture1.html file, also the truck picture. So I put all those files in there. I just moved them in there. Now what that lets me do is now we pretend that everything in here is on the server, even though the server is just on my computer. So for all intents and purposes, on the server, so we can actually access these files. So we do so by going to the web browser, as usual. And I'm going to go here. Okay. So the way to access the server is you need to actually have some name. So the name localhost is, this is getting back to your question, every computer exposes a name called localhost, just one word. That basically says if you're running a server on this computer on the regular port 80, that's the address, because like you don't have a domain name, right? Like, what is your computer called? I don't know what it's called, but my computer is just called localhost to me. Now you can't see my computer because I'm not making my web server public, but I can see it. And then I just go visit this site. So when I visit this localhost domain name, my computer will know to go look for a server on my own computer. And if you run on yours, it'll look on your computer. It'll obviously look on mine. It'll look on your own computer. And then I'm asking for lecture1.html. I'm just asking for the same file. So if I reload, to show this is a real example, if I reload, it will do what you think it does. It's really fast because it's on my computer, but it will load that file. Just like how this is on pgbovine.net, my homepage, it will load. I mean, it's not that slow because these files are small. But the key thing here is I am actually loading using the web server software. Right. So does this make sense so far? Okay, so I am running a server. So for basically from now on, just imagine that this is on the internet somewhere. Like I just don't. Yes, question.
Do you have like more than one server on your computer? Is there like localhost 1, 2?
That's a great question. So more than one server. So that's where the port numbers came in. So remember how the HTTP, the default is 80? That's like the default port number. So when you go visit a URL, like any URL here, let's see actually this works. Let's see if this works. :80. Yeah, this works. So usually after the domain name, you put a port number. So 80 is the default for whatever. So you put a port number. So 80 you don't have to put. But if you actually run a server, multiple servers, to get to your question, you can run them under different ports. So if you have one, the default one's under 80. If you can run a second one under like 81 if you want. And here I'm trying to go to 81. It's not going. All right. There's nothing under 81. But nothing stops you if you set it up right from running 1,000 servers on your computer. And this is the port number is the way to differentiate the addresses. That's a great question. Yep.
So can you only access that localhost site on your computer?
Yeah. So at this, well, yes. So at this point, I can only access it on my computer. Well, if I say localhost, I only access my own computer. If you want to access my computer, I will have to start my server and do some configuration to expose probably the IP address. And then maybe you can type in like blah, 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 and go to my computer. But I haven't set that up.
Okay.
Yep.
What if I have two lecture1.html and like on a different directory?
Uh-huh.
So which one the server knows how?
Good. It's a good question. So let's actually try that. The question of different directories. So this www folder was configured by the server. So they configured this is the / directory. So if I can actually put stuff. Let's make a new directory. We have to set the permissions, but let's make a new directory called more stuff or something. And let's copy the lecture 1 into that. So this is basically a lecture 1 under more - stuff. If I set the permissions right, it should work. It might have some permissions issue. Let's try. No, it worked. Okay, good. So this is using the version of lecture 1 in the more stuff directory. Make sense? So does this make sense why there's no picture here? Actually, that's a good question.
Because you didn't put that file in
Good.
there.
You're going to put the file in there, right? Because I said truck.jpg, and there's no truck here, right? So I should say .. /truck for there, because .. means getting back a folder. So that's great. So actually, we copy the truck in here, too. So if I copy inside more stuff, this is a great question. So if I copy it, now the truck is in here. Now I see the truck, right? So yeah, so the answer is this www directory is the root directory, and then you can make subdirectories under it, however you like. And it's set up by the web server software. So everyone you set up will have some basic directory. And this works if you're on the internet too. It's not just on your computer. Cool. So we have the local server here. This is great. Okay, but this doesn't really get us anything more than we had before, right? I mean, all this gives us is just a little more convenient. So I can start. The reason why I'm doing this is because I can edit all the code on my computer and run it, so I don't have to go log into a server somewhere else. And even if my internet is down, I can do the rest of the class, right? So if the network goes down, we can still have lecture. Okay, but I want to show the image that it's identical to having it be on the internet somewhere. Okay, so next step is, how do we use a CGI script to print a static web page? So what do I mean by that? So this seems like a weird question, but I'll show you what I mean by using a script to print a web page. Okay, so this web page, the way we access it is we actually, we're all on the same computer here, but let's still make our funny drawing. Pretend like there's a server somewhere else. There is literally a file called lecture1.html on the thing. I make a request, the server grabs it, sends it back to me, and I get the file. What we're going to do now is a little more indirect. What I want to do is I want to actually have a program on the computer. I want to have a program. I'm going to write everything in Python and JavaScript mostly, but I'll kind of explain the syntax to you. So I want a program called lecture1.py or something for a Python file. I want to make a request and have the server actually run a script or a program. I want to have it run some code. It doesn't matter what language it's in. I'm just going to choose Python because it looks simple. But I want to have some script now running and doing something. I want to have it do something, and then it generates an HTML web page and gives it back to the user. And as the class goes on, you'll see why we want to do this. So I'm going to create a lecture1.py right now, lecture1.py file. Erase everything. Okay, so where are we? We are in the text editor, or lecture 3, sorry. Did I say lecture 1? Yeah, lecture 3, same thing. So I created lecture 3 py file here. Okay, so as a matter of logistics, what happens is these CGI programs that you're reading about. Yes, question?
In the readings, they were mentioning using C programming. Do you have to do that, or is it
No,
JavaScript?
that's a great question. So you don't have to program CGI script in any particular language. That's actually a very central concept. It's just, you just need to be able to run code on your server. It could be in C, it could be in Java, it could be in Perl, Python, Ruby, whatever.
In C, you had to turn it into HTML anyway, so you have to
Yep.
deal with everything, right?
Yep, so the goal of the CGI script is you have to just print HTML no matter what. You can do it in whatever your favorite language is. You make up a language and do it in. As long as the code runs and generates HTML, we're happy. We'll talk about JavaScript in a second, but just hold that thought. But yeah, it doesn't have to be in C or in any language particular. So I'm using Python for this class because it's just the shortest code. Okay, so as a matter of logistics, though, from the readings, a lot of these CGI programs, you actually need to put in a special directory before the server will recognize that it's a special program. So usually it's called CGI-bin. The web server software I installed created this folder for me. So it usually has to create a folder called that, and it does some magic configuration. But what you need to know is whatever stuff you throw into here will actually run as code. It'll actually try to run it as code on the server. Whereas everything you're throwing not in here, for example, this HTML file or the bear picture, it will try to just load that file directly and throw it on the screen. So I just made a copy. Actually, let me just do it live. Okay, I'm just going to make a copy of lecture 3. I'm just going to delete it, and then I'm just going to make a copy of it, just to show that this is all live. So the lecture1.html file, this was the HTML file, right? This was the file that we loaded. I'm going to copy it. I'm going to paste it in here. And what I'm going to do is I'm going to rename this. All this code will be online afterwards. So lecture3.py. So I'm going to name this a Python script. Yes. Okay. So now what I can do is I can try to visit this URL, lecture3.py. Just ignore all the other stuff that's added for other lectures. I'm going to go visit this URL. Actually, first of all, I want to see what this lecture3py is. I'm just going to open it. My text editor. Where is it? It's here. I'm going to drag this. Okay, lecture3py, even though I named it a Python file, is just the HTML file, right? I didn't change it. I just copied it. This is straight up the HTML file. So if I try to open this, it no longer thinks it's an HTML file because one, it's .py, and two, it's in this weird CGI bin directory. So if I try to visit it, some like weird thing will happen, right? So this means, this is kind of an error you will inevitably see many times as you're developing your apps, is that like something died on the server. What this usually means is either your permissions aren't set or your file is not producing the right output or stuff. So you're going to see this a lot in the beginning. But basically it means it's trying to load it and something funky is happening. And the reason why is it's because it's trying to run this piece of code as Python. But clearly this is not Python code, right? This is just random HTML. So just to show that there's no magic here, I'm going to go back to the file. So this is more of my files. I'm going to open a command line prompt in Windows. This is the Windows command line. I'm just going to run Python. So it's in Windows you have to get to it. So it's Python. So I'm going to run Python with lecture3.py. So what's going to happen if I try to run this program as a Python script? Yeah, it'll just die because it's not Python code. Yeah, actually it dies in the very first line. Right? Like this is just, it's not Python code, clearly. It just dies. Good. So in order to have any hope of running this, we need to actually make this a real Python program. So I'm going to start writing some boilerplate code to do that. Let me go template 1. Okay, so the first line we usually write in your code here is, let's see, we're going to write this weird line here for Windows, particular 2.7 python.exe. What this line says is that we want the server or whoever is running it to interpret this as a Python program and run this program with the version of Python on my computer. This just happens to be what Python's installed on Windows. On your Mac, it might look like something like that. Well, I'll put all this online later. So, but on Windows, this is what it is, for my computer at least. Then what we want to do is we're just going to write Python code. So for those of you who are not familiar with Python, this is a crash course. This is literally the extent of your Python code writing for now is just printing stuff. So we're just going to start printing stuff out. So the first thing we're going to print is content-type, capital type, text/HTML. And then print, this is a comment, don't forget, then extra new line. Okay, so what did I just print here? You remember from last lecture? Yeah?
It is the content, it is the type of content that will be delivered to the service.
Right. So it's the HTTP header, right? So this is the header of the HTTP request. So recall that when I visited, whoa, it's messed up here. Well, I can still use this one as an example. Oh, this is big. Use a small one. When I visited lecture1.html, recall that the header of the HTTP response had a bunch of extra stuff, but I had this exact line, content type text HTML, right? Had that in it. Has a bunch of extra stuff. It turns out you don't necessarily need it, but you really do need that line because it needs to know what it is. And the other essential line is this blank line here. This really messes people up sometimes if you're not used to it. If you don't have this blank line, the whole thing will just give you an error. You need an extra blank. That's just part of the HTTP specification. You need an extra blank line. So what I've essentially done with those two lines of code is print out this and print out the blank line. So I've been setting up the header for the HTTP that it's gonna print out. And then what I'm gonna do is it's actually fairly, and this is a print just in Python. For those who know Python, just print by itself just prints an empty line. This is just a comment. I don't need this. We don't necessarily do this. So this prints a minimal HTTP header. And now we're going to print the HTTP body, which is the HTML file representing lecture1.html. So now this whole thing, we just want to print this as a giant string, pretty much. I'm going to remove the comments because it doesn't matter. So let me just remove the comments. I'm just going to compactify some stuff just to simplify things. I'm just killing comments, killing some empty spaces, a lot of stuff down here. Okay, so what can you do? You can just print out one line at a time. So we can say print HTML. This is pretty exciting to watch live. Print. You get the point, right? You just keep on printing stuff. So in Python, fortunately, you can do a multi-line string. So if you have a triple quoted string, you can actually have a string span multiple lines. So that's a nice revelation. So this actually prints the string that represents this whole glob here. So I don't have to say print on every single line. I'll keep, let me see, do I need to spring? Yeah, I'll just keep doing the single lines for a little bit just to, well, let's do, where am I supposed to stick in stuff later? Well, let's just do single lines for a bit, but you'll see all this example code online. I have to close all this. Print. I want to illustrate something by having it all be multiple lines, but the idea is I'm just wrapping all this text in just print statements. Do we care about anything else underneath? Whatever. I'll just kill the rest. And this is also the beauty of, notice how you don't need, the HTML doesn't care about spacing, right? Because if it cared about spacing and tabs, this would be annoying. But it doesn't really. You could just, it ignores all the white space. So now I'm going to save this file and hope this works. Oh, I just drew out here. So now what happens is I have a piece of Python code. This is just Python. That is just a bunch of print statements. Right? This is a legal Python program. It doesn't really do much. It just prints a bunch of strings to the terminal. So I'm going to run this. This is Python. Remember, this is the Python code that we're trying to run before. See if I don't have syntax errors. I'm going to run it. And good. It's no syntax errors. So if I scroll up, the thing I just ran, what did it print? It printed content type text HTML, as we expected. Printed the blank line that's really important. And then it printed all the stuff that represents my HTML. So hopefully this should be no surprise. It's just printing what I said to print. And then we're done. Does that make sense? So just printing everything else. So I'm just saying this is running as a Python program on my computer. Like it's just what you expect to happen. Okay, so now we have a legal piece of Python code, and we've put it in this special CGI bin subdirectory. So we should be able to run this, hopefully, from the server. So now let's actually revisit again. Remember last time it wasn't legal Python, so it had this error. So let's see if it actually works. I'm going to reload. Good. So notice how I ran a piece of Python code. This is not HTML, it's Python. And it printed out the HTML web page. This is the exact web page we wanted, right? And again, why is the truck not there?
No file.
Yeah, there's no file, right? The truck is not there because there's no truck in here. So one way to fix it is to, you can move the truck in there like we did before, or to change this to .. Right, so .. means we're not looking for a truck in here. We're looking for a truck up one directory up. So there's some videos online I can put on Piazza about what the command line is and how these directories and paths work. But .. means go up to my parent directory and find the truck picture. Yes?
Does that .. work for Macs as well?
Yeah, so the .. actually, that syntax works for all operating systems. Yeah, because it's actually part of the HTML standard. So it's, yeah, the slash is the standard one. So I'm going to save it and then reload, and the truck is there, right? Because I put the .. truck. Yes?
Is that why when you're looking at source code of a website that uses databases, you never see anything with the database in the source code? It's all assembled like.
Yes, that's a great, yeah, so the comment, the observation was, if you're, on Amazon, right? That's a great example. On Amazon, there's gigantic amounts of databases in the back end, but you don't see it in the source code because, like you said, it was all assembled on the server. It grabbed all stuff in the databases, it smushed them all together and printed it out as one giant file. So you don't actually know what databases they're running. You just know the end pictures and text. Yeah, that's a very important point. We'll get into databases Thursday, so that's actually a really important point. Other comments or questions? These are good. Yeah?
Can you change what code you print dependent on the HTTP request?
Very good, very good. We will do that in about 10 minutes. You're really getting ahead. This is great. Yep?
If you were to view source
Mhm.
on this, would you be seeing all the print statements, or would you see a bunch of HTML without spacing because we ran it in Python?
What would you guess?
Um,
We'll find out in 2 seconds.
honestly, I mean, like, I'm kind of 50-50.
Okay, all right. So if we view source, it actually is the HTML.
Okay.
So, I mean, there is still spacing, right? There is still kind of spacing because
Oh.
there are some tabs, right? I mean, if you actually,
Yeah.
remember, we actually put some spaces in there, right? Because if you actually look at the Python we're running, these are actually really important points. I want to spend time on this. We're running the Python. There are spaces, right? There's just not like spaces between, I guess. But this is exactly what you see on your source. So if you view that HTML, you can't know that it was produced by Python, right? And same thing on the database. You have no idea what produced this. You just know it's some HTML. That's actually a super central point. That by looking at the source of web pages you visit every day, you don't know what actually generated them. For all I knew, someone wrote this by hand, someone wrote this using a program. I mean, you have a clue here because it says lecture3.py, so it's probably a Python program, but someone else could name it something different, right? But yeah, so when you view source, by the time it gets to your browser, it is all HTML. There's no more Python left because the Python ran on the server. So to recap that point, because it's really important, is web browser here, server. I don't know why I draw the server as a big cylinder, but I started doing that, and I'll just stick with it. I guess the cylinder is like a big hard drive, but so there is, what is it called, lecture3.py? You make a request, lecture3.py runs with Python. Something happens, and then it prints out a bunch of HTML, and then this just kind of gets sent right back to your thing. So it's all HTML by this point. There's no more Python left. Okay, so, well, yes?
What's the point of doing this? Why don't you just get the...
Yes, exactly. I was just going to get to that. Everyone's preempting what I was going to say next. This is great, actually. That means that the pace is going well. Great, so what's the point of that, right? So the point there is absolutely no point in this. I've done nothing new over that. I mean, you can even see the proof, right? They look exactly the same, right? There's HTML there, and if you actually just see, there's HTML, and then I switch to the CGI thing. Like, it's exactly the same. And I mean, the code, if you view source, is almost exactly the same, right? It's there's some extra spaces, and there's comments here, but it's pretty much the same. Okay, so why would you ever do this? So this is probably not a good idea to do if all you're doing is just just printing a big string. But what now we give you is now we're actually running arbitrary code on the server. So we now are opening up to all the stuff you're learning in programming and computer science, and imagine all the stuff that you can do with programming. Whatever your favorite language is, whatever your favorite libraries are, whatever your favorite toolkits are, any code you can run on your computer now, you can run on a server because it's just a computer, and you can make that do stuff with your web page. So that basically, this opens up the doors for basically doing anything you want, good or bad, I guess. So let's do the first thing, which is pretty innocuous. The first thing is, what if we want to actually generate web pages that have content that's dynamic? So we've just covered this, right? How can we use a CGI script to print a static web page? Now you all should see what it means. A static web page, just a static web page, and we just printed it out. Literally, we printed it out. Nothing fancy happened. So we did that. So now we're going to go to the next step of how do you use the CGI script to print a dynamic web page, a web page that actually depends on data and changes. So we're going to keep building off this example. Let's go here. So now we have Python code, so you can do whatever you want. You can use any Python code you want. I'm just going to keep things pretty simple for this example. So we're just going to use, let's see. Let's use, there's a useful import. This is called import CGITB. So this, these two lines, what it does is that it imports some debugging library that's useful so that if your code breaks, it actually prints out a web page that says where your code is breaking. So, because without it, you get that 503 error or 503 or whatever, and it's really not very useful. But if you're using Python, this is a super useful line to have. I'll show you what happens with it. Again, it'll all be in your code. If you're using another language, they usually have something like this that you import in the beginning to give you better debugging information. So just have that in the beginning. Okay, so we're going to import datetime. So what is datetime? Datetime is just a Python library. So I'm just going to run Python. So I'm running Python in the prompt here. It's kind of the bottom. This is the Python prompts. If I do not want that. If I import datetime here, it imports a library. So I can say datetime.now. You don't need to know this. These are just library functions. This is just a function that prints out the current time in some object. So if you notice, it's September 8th, 2015, hour, minute, second, millisecond, microsecond, something. So every time you run this, it's different, right? I mean, you're going to, whoa, time passes. All right? And you hopefully time keeps on going up. All right? Unless something really weird's happening. Okay, so this is actually some object. It's some datetime object in Python that you can play with. To make this a string, you put the str in front of it. these are all just Python specific functions. So str turns into a string. So if you actually look down here, it actually prints it as a somewhat nice looking string of year, month, day, down the string. Right, so this str thing. So what we're going to do is we're just going to make a string with the current date time and just put it on our web page. I just want to show this is just a Python function. There's a bunch, you can play with millions of Python functions, or your other favorite language, you can play with functions. So I'm just going to copy this into my code. I imported datetime. So where am I going to put this? I'm going to put this, where did I put it in my notes? In H2. Okay, so remember how H2 is my subheading now? Recall on the web page, it's my subheading. It's this one right here. I don't really like that. I want to get rid of it. So if I comment out this piece of code in Python, if I comment out and save it, if I save it, then it should not print out my subheading, right? There's no subheading anymore because I just commented it out. So if I put it back in, there's a subheading. If I comment it out, if I comment it out, save it, no subheading. That make sense? It's just code. Okay, so instead of subheading, I want to print something else. I want to print what I just said, string of datetime now, that. So that just prints that string that represents the current date. So if I save and I rerun, there we go, there's the string. Seems magical. This is the current time. Now, the more magical part is if I reload, that thing should be different now, because the time is different. So I'm going to reload, and it's different, right? And I reload, it's different. So now we have the magic of generating an infinite number of web pages that contain the current time, which is all super useful, I'm sure. But the idea is there. The idea is I have just executed arbitrary code on my computer and put it on a web page that anybody in the world can see. Well, just on my computer can see. But if this was on a server, anybody in the world can see the current time, which is clearly a really useful web page. So questions about how this is working? Yes?
I think the JavaScript can do the same stuff and works better with the HTML. So is CGI only for the person who don't know how to write JavaScript or PHP?
Good. So that's a good question. So you're saying you can do this in JavaScript on the web page itself. That's right. That's right. So you can do this in JavaScript. So I will, let's do, so you had two questions. There's JavaScript and there's PHP. Okay, so I will give you, here is this picture. So there's your laptop. There's the server somewhere. So what we're doing now is we are in our web browser going here to the server. We're running Python code, and we're giving back, the date. And this looks pretty trivial. Right? We're going all the way to the server just to fetch the date. So it seems kind of useless because your web browser itself, inside the web browser, runs a language called JavaScript. So how many people have heard of JavaScript or used it before? Good. Most of you have used it. This is great. So there is a language that runs inside your web browser called JavaScript. What JavaScript lets you do is that it lets you do a lot of stuff. It's a very general purpose, very powerful language. So you can actually just write JavaScript code in your web page that prints out the date for you, right? And you don't ever have to hit a server. You don't ever have to see any of this stuff. Just keeps it in your computer. It's all in your web page. Everything is good. Yes?
Can JavaScript communicate with the server?
Good question. Can you have your JavaScript run and communicate with the server? Yes, it can in lecture 7 or whatever that is. Yes. When we're in this world now, we're assuming it cannot, but it will in lecture 6 or 7, or one of those. Yes, that will be coming up. So for all intents and purposes now, your JavaScript is stuck in your browser. So it's fine for these things like print out the time, doing image processing and stuff. But if you actually want to do stuff on a server, you need to write in another language. So Python, PHP you mentioned. PHP actually has the same power as Python because it's running on the server as well. The only thing that runs in your browser is JavaScript. All these different languages, Ruby, whatever you want, run on the server itself. So the advantage of having a server is if you have a 100 gigabyte database, you probably don't want to copy that into the person's laptop in order for them to use it with JavaScript. You probably want to keep that on the server and have the person use it that way, right? But that's a great question. So this class, we will start covering JavaScript in lecture 6 or 7, the second part. But for now, all the stuff is on the server. Yep?
For the PyCode to run as code, you must put it into a specified direction and with CGI.
Right.
Other native not one.
Yeah, so the question was, or the comment was, in order to run this stuff as code, instead of just loading a picture, let's say, you need to put it in a special directory in your www. Usually it's called CGI bin. Yeah. So the way that works is the server software sets up some special directory for you to put code in, and it's dependent on the server. It's usually called CGI bin. And if you use a different server, I mean, there's like 1,000 of them. It may be called something different. Yep.
In the readings, the example was with C, and then the extension was not that C, like in this case that UI because it's Python. You have to compile it first and then use the compiled version, right? Another extension.
For the Python one.
No, for the C.
For the C one.
In the readings.
Yeah.
There's an example using C.
Right.
You have to compile it first, and
Yep.
then the generated file. That's what you put in this folder.
That's right. That's right. So the question was in the readings, you were writing some .C code, right? So how many of you have written C code for classes or for other stuff? Okay, good. So you all had to suffer through that. Good. Perfect. I suffered through that for 10 years before I just did web programming. So this is great. So you write C code, but clearly you can't just run the C code, right? If you try to run C code, it doesn't do anything. You have to go through a compiler called GCC or something, right? And it produces some program, and then you run that program, right? So then, as you mentioned, that program that you compile will be put in the directory that you're running, and not the source file. I mean, you can put the source file if you want, but yeah.
Is CGI bin a reserved name, or if we change the names of the directory to like?
Would it still work? Yeah, I think it is reserved. I mean, it's not reserved, but it's it's the server. So what actually goes on is that the Apache server that this amps thing is, there's a configuration file somewhere that says blah 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 amps www.cgi bin is for running these scripts. You can change that to another thing and then change the directory. But yeah, if I change the directory name, it won't work because the server thinks it's CGI bin. That's a good question. Again, all these things are not magical. They're just configured somewhere that you have to find out. So we just want to stick with a good default. Okay, cool. So now we have a lot more functionality. Well, the time is still ticking, which is good. And the important thing here is I'm not making a web page manually, right? I've just written the same Python file, but it's generating a bunch of different times. Okay, so that's good and all, but we want something a little bit more. Where's the last one? It is this one. Okay, so now we have a half an hour left. Now we have a printed dynamic web page. This is good, but I think to your question up there is you want the user to be able to provide some data, right? And then we generate a web page. I haven't provided any data. I just made the program print out the current time. This is like kind of useless for actually interacting with the site, right? So what we really want is we want our script to take user input somehow and then generate a page based on what the user said. And one way to do it is in what's called a URL query string in the string of the URL. So I'll give you an example from a simple search engine. So there's this search engine called DuckDuckGo, which is like Google but much simpler. The URLs are much simpler. So what I want to illustrate is this. So if I actually visit a URL called duckduckgo.com with the question mark whatever thing, Q equals University of Rochester, this, if you squint at this hard enough, it looks like there's some variable in value, right? It looks like there's like you have a URL first, which is a thing, and then there's like a Q, and that equals University of Rochester. There's some pluses, which represent spaces, but it's sort of like you're making a query for University of Rochester just from the URL itself. So if I actually typed in, if you notice, if I actually typed in University of Rochester here, it will take me to this URL. So I can type this in directly. If I type in directly and press enter, it just goes to that page, right? So this is really like I am providing user input for the program, right? So if I write that, it should say that, all right? So it's the same web page, but I have this Q equals thing. I have something that I'm typing in to the URL itself and providing some data. And based on that data, it's doing something different. So clearly, this is creating a web page, right? This is some web page based on the search I did. And this is clearly creating a different web page, even though I'm visiting basically the same URL, right? So in the DuckDuckGo servers, it takes the string here and it probably parses it and does all sorts of fancy stuff with its search engine and algorithm. And in the end, it spits out this nice web page with all the search results. So in this way, a single web app can take in different user inputs and do different things, right, which is what we want to work toward. Otherwise, we're just printing out the time all the time. So how do we do that with our code? So we need to add a little bit more as we build up our example. So we're going to go back to our example of the lecture 3. We need to import something else in Python. We're going to import this thing called CGI, which is the library for dealing with the CGI data. And we're going to do form equals CGI field storage. Again, all this will be up afterwards. What this says is that I'm going to take the data from the user somehow when you're running on a web page and throw it in a form variable so that I can access it. So what does that actually mean? So now my data from the user is in a thing called form. I can name this X or whatever. I'm just going to call it form. Now I'm going to go down here. Remember, this is a bunch of web page browsing code. And under my header, I want to say something. I want to print H2 again. I guess make it kind of big. Your name is : space plus form my name dot value plus H2. Okay, so let's stare at this for a little bit. Okay, so I'm just going to stare at this code for a bit to kind of parse it out for people who aren't as familiar with Python. Print, again, just prints a string. So what this does is that this actually takes one string, adds it to another string, adds it to a third string. Make sense? We're just adding 3 strings together to make one giant string. This is just a constant. It's just /H2. This is a constant. H2, your name is : space. Now this is the middle part. That's the more substantive part. This string in the middle, is actually grabbed from a variable. And what this variable is, it's called form. And then this is called a dictionary in Python or a hash table in other languages. You look it up by another string, which is the name of the key or the variable name. And it's called my_name. I called it that just arbitrarily. And then if you look that up and you do dot value on it, you get this property. You actually get the string that corresponds to the my name parameter. This is just part of using the API for this library. I mean, there's no particular reason it has to be like this. This is just how you use it. And if you look at the documentation for this, they say just write it like that. Okay, so what this does is it actually says it should print out a string called your name is and my name and then H2. So let's actually run this. So remember, my_name is the variable in the query string. So we're going to go over this a little slowly so we can cover all the bases. So let's go back to here. Happens all the time. Let's go back to here. Lecture3.py. Okay, so now my lecture3.py expects something from the user. So I'm going to reload and let's see what happens. 10. Reload. And then some crazy stuff happens. So this is the advantage of having that traceback, that CGI-TB module. Notice how it starts building my web page. My heading is fine. The date time is still fine. And then like something just blew up here in my code, right? It just like, this is like if your code crashes, it prints out some error. It actually just blew up and printed out the error. Fortunately, because we have this module enabled, it actually shows you where the error is. It says, key error, my name is not found. So we didn't pass in a my name to the web page, so it broke like this. So it printed out a reasonably decent error. I'm going to show you what happens if I did not put the debugging thing in. So we're going to go back to the same thing. I'm going to comment out the debugging. It says useful debugging. Let's comment this out. I'm going to save. And let's see what happens. I'm going to reload. And then it just like kind of dies in the middle. It's inexplicable. Because what it actually is doing is... let's view the source again. It is... Yeah, actually notice what happens. The source is incomplete, right? If you notice how it started generating the code, you're good, the time here, and then like something just blew up down here and it didn't actually complete the web page. Does that make sense? Because it actually died on this. Remember, this is all good. We're printing it. It's all good. And then right here, this line, it just crashed on. So it stopped the program. It just totally crashed. So the HTML it generates is only stuff up to here, right? So it actually generates an incomplete HTML. So what looks funny about this file?
You don't have close program?
Yeah, it doesn't have to close things, right? You're opening the HTML, opening the body, and there's no closed body, closed HTML. This is a broken HTML file, right? But why is it still, why does it still like render, right? Like this should not render, right? So why does it still rendering on the web page even though it's half broken? Yeah.
It's because it reads top to bottom.
Yeah, it's one because it reads top to bottom. So you can logically think, yeah, it kind of that is okay, and then it's broken. So the other important aspect is that web browsers are actually meant to read broken HTML files pretty well because it wants to display something rather than displaying nothing. So you could imagine a web browser that just says this is not an HTML file. I'm done with it. But most web browsers actually try to read HTML that's kind of broken. And the fact that they did that since the beginning means that actually most web pages you visit actually are broken HTML. Because it's actually very hard to write HTML, especially big pages, and have everything match up. If you're writing it by hand, you're probably mismatching something, but the browsers don't really care. So they've taken a lot of care into rendering broken HTML, which one could argue was a good thing for the web because it means that anybody can make web pages and type stuff out. So imagine like if your C programs, if you could run broken ones, right? It'd just be weird, right? It has to work exactly or else the whole thing crashes. HTML is just the opposite. It basically anything you write gets rendered. It may not be what you want, but it tries not to break. So that's actually a good case study in this. Let me put the debugging thing back. So the good thing about debugging is that when it crashes, at the point of crash, it actually prints out the error for you. Yep.
So the crashing happens on the server's computer or on the user computer?
This right here?
Yeah.
So this code is all running on the server, and it's generating a piece of HTML that's running on the user's browser.
So that means that the crashing happens on the server's computer.
Yes, that's right. The crashing happens on the server's computer. That's right. So that's good. That's a great point also. So here's my browser. Run this 1,000 times already. So my drawings are getting worse. But yeah, the crashing happens here, right? So we run. It kind of starts generating HTML, and then it crashes and it stops sending stuff. So the crash is happening on the server, not the user's browser. So the user's browser crashes, they'll just like die. But yeah, that's a great point. But of course, on these examples, they're both on my computer, right? But technically, it's the server. Okay, so let's fix this error. So the way to fix this error is we need to actually pass into my name. So the way to do this is a question mark. My underscore name is that. So let's read this URL. So what this says is I want lecture3.py, which is the name of the file. So it's a little small. Question mark means we're ready to take parameters in the URL. So after the question mark, the format is a pair of, or several pairs of the keys equals values. There. So I'm going to pass that in. And if I do that now, and all works well, I'm going to reload. It's still, wait, what just happened? Did I not have this? Sorry. Yeah, so that works right there. See? So it actually printed out my name. And the reason why I printed it out, once again, is because it went through the form. Where's the form? Form is here. Form equals CGI field storage. And then down here, it said your name is, and then this value was Philip first, and it just printed it out. Yes?
How come this time it didn't crash?
How come it did not crash? Right. So it did not crash because I actually passed in a valid my name equals. So if I did not pass in a my name, it will crash because it's looking for a my name in the Python code, but I don't have a my name. So if I pass in a my name, it will not crash because it will find it. And then it will print it out to the screen. So this is actually making, if you squint again hard enough at this, you're going to get Google, or sort of, right? I am passing in some data, and I am running on the server and printing out, doing something with that data. So if you say that, it'll say that, right? So I am now able to generate web pages based on user data. Like that. So this works. Yes?
Like where it will look for all the arguments from the URL. Like if you get like multiple stuff you want to continue, like where should I put them?
Yeah. So multiple arguments. So we have one so far, right? Yeah. So to do multiple arguments, this is the next step, is you can, in the syntax, you just put it, you put and then, let's say my age equals 32 or something, equals 32. So you put, this is the syntax. You have an and then you have another thing. So each one of these is a variable. You can also pass in lists of stuff. There's more complicated syntax, but the simple thing is something equals some string. And let's actually do the age. So if I do this now, it doesn't do anything fancy because I'm not using my age. But I can actually just augment the code. Since you just reminded me, I'm just going to copy and paste this code. Your age is, and we're going to use my age here. So recall, this is my name and my age. We're going to pass in my name and my age here. Save it. I did not save. 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 And now if I pass in my name and my age here, it should hopefully display your name is your age is. Let's try it and press enter. And there we go, right? So that passes the second variable along. Yes?
So obviously, usually the user isn't going to enter the URL with all the URL queries. So is this basically just a way to pass information from one script to another?
Yeah, so that's a good question. So this is not the best user interface. As you can imagine, nobody interacts with internet, right? Typing stuff in the URL bar, unless you're trying to get illegal content somehow. You know, you probably don't want to do this. So one use of this is for scripts or computers on the internet to talk to each other by generating these URLs and talking to each other. That's actually a really good use case. The second use case would be actually having bookmarkable URLs, right? So imagine I went to the home page and I searched for there. Notice how it actually displayed a really nice URL for me. So if I can now copy this URL and give it to my friend and email it to my friend and have them go to the exact same page I'm going to. So it's not only for machines to talk to each other, you can actually have this using for humans because now I can bookmark this URL. I can email people this URL. So that's why if you actually look at a lot of your emails and stuff, they might have like crazy URLs, right? And the reason why it's crazy is because it probably has all these parameters in it, like Google Maps or whatever other, Amazon or other URLs. So that's a great question that you can bookmark these. But getting back to the other point in your question was, how do users actually interact with this, right? You don't actually type it in manually, and that will be the last part of the class will be that. Let me add one more thing in my image. Okay, so there's no reason why these things I'm just printing out as strings, right? Where am I? Let's close this, close this, close this. Okay, we're back to my age thing. I'm just printing these out as strings, but there's no reason why I need to do that necessarily because I can do whatever I want with it, right? So let's add a new parameter called myImage equals something. Let's say cat.jpg. Again, I'm not using it yet, so it's not doing anything. So let's actually do my image. So now what I can do is I'm going to put let's do this. Okay. So now remember this truck picture, right? This is just a string, right? I can just print out whatever I want. So let's erase truck. And then I'm going to really delicately put these single quotes. I'm going to show you what I mean by this. This is a little bit hard to read. But what this is that the single quote is quoting the string. This string is this, and there's a double quote on the end of it. So this is all inside the string. So I'm putting a double quote. And then here there's another double quote, and there's a slash and ending. So this single quote is really just Python says is a string. But inside that string, there's actually two quotes here, right? They're double quotes. So this is a little bit tricky. But what I want to do is I want to actually stick some word inside of here that's for my data. So I've kind of broken up the string into two. So what I want to stick into here is I want to stick form my image dot value. So if I do all this right, then based on the myImage variable, I'm actually creating an image with the source pointing to a different image. So first of all, I want to make sure I have the picture in my folder. Do I? No, I don't. Okay, so I'll do a dot dot. Actually, let me just copy it in just to show you. So I have a cat picture, right? There's a cat. It's great. I'm going to copy it into the CGI bin, so it's the same directory. So it's all good. It's the same folder. Now, what if I do this? If I do myImage equals cat.jpg, if all works well, didn't work. Where is the picture? Do I not have permissions on this? Let me, it's a gray, oh, I know why. Okay, this is a little annoying. So as you're debugging these things with web apps, you're gonna often get things that don't load. This is a live lesson. It turns out I debugged this last night as I was practicing. it turns out in CGI bin, I think someone mentioned here, everything here is run as code, and it doesn't load the file. So when I put that cat in there, it didn't know it'll load it as a regular file. I thought it was like a piece of code and ran it. It probably blew up my computer or something. But you can, you shouldn't have cat pictures inside the CGI. You just keep it outside. So the way to reference that is remember the dot dot. So if I do dot dot slash cat, this will create a string that's the upward one directory in cat. So if I do that, and press enter, there's a cat. All right? And I can do the same thing with dog and bear and whatever. So now this is starting to get a little bit more interesting, all right? So we have all that. And that's because these are pictures I put on my computer, right? So, I mean, there's no magic here. I put these pictures. Now, the next cool thing is, if I dare do a Google image search, it's the most innocuous thing you can search for. I don't know, is a safe search on? It's not on by default. That's kind of crazy. All right, let's take our favorite bird picture. Okay, so I'm going to right click, open the image in a new tab. So this is the URL. It's pretty cool. So now the cool thing is the image tags in HTML, they don't have to just be files. They can be any URL on the internet. So I'm just going to copy this. I'm just going to throw this in here. So my image equals, I'm just going to throw this in here. Whoa, this looks long, but this is a little bit too long here. But hopefully y'all can see what this is. My image equals is just a giant string, all right? So if we do this right, this is actually the picture, all right? That's pretty cool. So there's nothing that says that your picture has to come from your computer because we're on the, of course I have to be on the internet. Or if I'm not on the internet, I can't see this. But because these are just web pages can access images from any other web page. And now you're starting to see how you can build sites like Reddit or BuzzFeed or whatever. They're just hosting images and putting names and everything. So that is basically the layout. So you can imagine putting anything you want in here. And this is all just the same Python code, right? I just have one piece of code and I'm creating all sorts of different images. Okay, so in the last 5 minutes or so, we're going to get to how do you actually interact with this. That's not, actually let me guard the code a little bit better. So right now what happens is if I don't have my image, oh, actually, does it default to trunk? Oh, interesting. I thought it did not default. Huh. Did it? Did I save it? Huh. I'm curious why this goes back to the truck picture, because I thought it should be broken, but I will look into that. Anyway, so like you mentioned in the back, you probably don't want to manually write these URLs in. One other way to interact with this is called using a form or an HTML form, using what's called posting data to the form. So I just made an example on this. I'm not going to type out the code manually, and it's called Lecture 3 form template. Okay. I'm just, in the interest of time, I'm just going to copy this. Lecture3.py. Okay, so what this code is HTML. It's just standard HTML. And there's a head, title my first form, blah, blah, blah. There is a thing that says, basically, the only thing in the HTML is this right here. These BRs are like new lines, so just think of them as just putting a new line. H1 is like a header. It says, please enter your info. There is a form tag now. It's a new thing we introduced. There's a slash form, so these things close each other. Inside the form, there's a bunch of stuff. There's an input field. Name equals my underscore name. There's text, there's size. There's my age, my image. Each one of these input fields is a text box, is a one-line text box where you can type stuff in. In the HTML documentation, you can find all sorts of things like radio buttons and checkboxes and multiple lines. The input type text is just the most basic sort of input. So if I look at this, I print out name and then I put some box here, and then age, put some box here, image URL, put some box here. Last one is input type submit. This is a special submit button. There's a reset button also, but we don't really need it. So there's a special submit button that it creates. So what does this look like? I'm going to go visit, what is this called? Lecture 3 form template. This is Lecture 3 form template. So recall, this is just a regular HTML file. This is not a Python file, so it's out here. So this is what we look like, right? We have please enter your info, text, 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 submit, reset button. So you might have seen this in like forms somewhere on the internet. You're entering your information for whatever websites you're signing up for. It kind of looks like this. It looks prettier. Okay, so we have this. Now the key parts of the logic here in the form is these. So there's a name equals my name equals my age, name equals my image. What this means is that whatever the user puts into those boxes, when you send the form data to the script on the server, whatever the user puts in here will be saved under my underscore name. Whatever they send under age will be my underscore age, and whatever they put under image will be my underscore image. We just need to name it the right things. Now, where do we send this data? When I hit submit, when I hit this submit button, where is this data actually going, right? I hit submit. I want to submit this user data somewhere. And the where I'm submitting is this right here, the action field. The action is, it says CGI bin / lecture3.py. This was exactly the script we've been working with all along. It's under CGI bin because this is, this recall is in our, this form is, where's it, lecture 3? It's in our directory, home directory, a root directory, and then we have to go inside CGI bin to get to the lecture 3, right? So we need to put a path that goes inside. There's no reason, again, this needs to be on your server. If this is a form that's being sent over the internet somewhere else, you have HTTP blah, blah, blah over the internet. It just happens that this is all on my computer. And the next thing is this method equals post. So in the readings, you've seen get requests and post requests. Basically, this means that send this as a post request, which means that we're not actually going to send in the URL. It's using a different format. The advantage of a post request is seen in readings that you can send a lot more data that way. Is there a question? Okay, all right. So you can send a lot more data in the post request than the get request. So reasons you use a post request is, imagine you're on a website and you're trying to upload a picture. So like you have to like upload your like profile picture somewhere, and you say like choose my picture and upload. That usually uses a post request. You wait for like a few seconds, it uploads to the server. Just a bunch of ones and zeros that uploads. Okay, so given that, what does this actually do? So that means that once I enter my data and I click the submit button, the form knows to go visit this web page or this script with the bindings of these three things bound to the variables. So this is how I get to actually pass in data. So let's actually do this. I am here, so I'm going to put in my name. Some extra P's on here just to show it's different. All right, here, and then where's the URL called? Like cat. Well, let's do the bird one. So this is convenient because then you can choose whatever you want. So let's do the bird one and paste here. Okay, so I have the data here. I'm going to hit submit, and when I hit submit, it'll actually visit this web page. Like, is that lecture 3? Oh, I see. This is not like, yeah, this is the lecture 3 one. It'll visit the lecture 3 one and do our thing. Let's see if it works. Yep, and it does that. All right, so this is lecture3.py, but notice how now there's nothing in the URL. And the reason why there's something in the URL is that the URL is only used for what's called get requests in the query string. This is a post request, so it's all actually hidden behind the scenes. But it does what I want. It has this, it has this, it has this. I can go back, and if you visit this, if again this is on the internet, and you visit it, you know, was it dog.jpg? It will do that, right? And if someone else visits it, and bear.jpg, it'll do that, right? Yes?
If you want to share the post URL, can you like put the information back up?
That's a great question. Yeah, so the question is, this URL is not very useful now because if I copy this URL and give it to someone, it actually dies, right? Because there's no post data in it. Your web page can, in JavaScript again, you can manipulate the URL and throw it back in. More likely what you'd actually want is you want to actually use a get if you really want to share the URL. So actually, let's do that. We have 1 minute left. Let's change this from a post to a get, like that. And now let's see what happens. Not sure this will work. Let's try it. That. Let's try it. This actually works, yeah. So if you actually notice here, now the only difference here, notice how it's all in the URL now. My name, my age, my image. URLs are encoded in some weird format, just for format's sake. But if you squint at it, this is the right URL, right? If I copy and paste, this is exactly the same URL, the Judy2345 URL. And the thing I change here, the crucial thing I change, is that in the form, instead of using a post, I use a get. So get means the URL is actually in the string. Post means it's hidden. That should be in greetings. We can talk offline about why you're using one or the other. One way that you just be hidden. So we will see you on Thursday, and that's everything. And sign up for Piazza. Check your email if you haven't signed up, and start thinking about partners in the next few weeks.